Welcome for another lesson. Today I would like to handle transformations. This is a sector where students get some challenges, but when they are made familiar with the concepts behind the transformations, then it becomes it becomes a strength, it becomes an area where people can get marks. So I would like us to clarify several transformations, what they entail and how to go about them. So I will enter the three main transformations in Book 2 Mathematics, even though I'll mention something in vectors which is called translation. And later on I'll be dealing with transformations and matrices in Book 4. So in the meantime, I'll be teaching the three main transformations, which are reflection, and enlargement. Let's mention something briefly on each before we example involving successive transformations, whereby we'll have a question where we'll be required to carry out a rotation followed by a reflection, then an enlargement, and we'll be okay. Therefore, a reflection, you find on a reflection you should note three main things: that the image and the object have the same size and shape. They have the same size and shape. Therefore, if the transformation is a reflection, then whatever is being reflected and whatever has been reflected, the image and the object, they should have same and same shape. Again, the image and the object should be, or must be, should be equidistant. They should be equidistant from the mirror line. From the mirror line. The mirror line is the plane where the reflection is occurring. The plane where the reflection is occurring, we call it the mirror line. Mirror line mostly abbreviated letter M. Therefore, from the mirror line, they should be equidistant and in opposite sides, I think. And in opposite sides. They should be in opposite sides and equidistant from the mirror line. And lastly, the line connecting a point or a vertex, a point on the object and the reflected point on the image should be perpendicular to the mirror line. Should be perpendicular to the mirror line. Line should be perpendicular to the mirror line. Or briefly, this is what I am trying to drive home. If we have an object here, if we we have an object here. Just trying to do a sketchy illustration. We'll be seeing real reflection in an example. Then you find this is an object, and this is a mirror line M. Then you want to reflect this object on this mirror line. Let's say it has points A, B, and C. So if you want to reflect, you should note that the three are very key. Image and object having same size and objects and shape, that is. Image and object being equidistant from the mirror line and in opposite sides. So if we have the mirror line here and object is here, definitely the image should go on the other side. That is the rule of reflection. Lastly, the line connecting a point on the object and the reflected point, the corresponding reflected point, it should be perpendicular to the mirror line. In other words, I mean, if you have to rotate, to reflect, C, point C for example, it should go perpendicular. It should to the mirror line perpendicularly. So it should be perpendicular. So this should be done by using a compass or a protractor. It should be very perpendicular, and after reaching here, this distance from C to M, it should be the same again from M to the reflected C prime after reflection. Similarly, you do the same to A. You bring it here perpendicular and then you proceed an equal distance. You get A, and for B the same. From B to the mirror line perpendicularly and to the opposite side an equal distance. So that is what we call reflection. Let me mention something to do with rotation. Rotation. Now, under rotation, three important things to define a rotation. Fully, then the anchor, the sender, and the direction of rotation must be stated. To define a rotation fully, you must state the anchor, the sender, and the direction of rotation. Let me give an example of what I'm saying. For example, a rotation about the origin. So origin is always the coordinate 0, 0. So that is the center of rotation now. Through an angle. Of 60 degrees in the clockwise direction. Therefore now, this is a fully defined rotation taking place about the origin or coordinate 0, 0 through an angle of 60 degrees in the clockwise direction. Therefore, if you got a Cartesian plane, this nature. Then you have a point here, and you want to rotate A. You bring A to the center, which is the center, which is the origin of rotation. Then after that, you measure the angle of rotation in the mentioned direction. The angle of rotation in the mentioned direction. Therefore, when you arrive at the center now, so in the clockwise direction, it is this direction, clockwise. Therefore, you will measure 60 degrees in the clockwise direction. Then you measure an equal distance from A to the center of rotation. You measure again an equal distance. You'll be able to get the A prime. Therefore, to rotate a point, Roman 1, connect it to the center first of all, to the center of rotation. Connect it to the center of rotation. Part 2, measure the angle of rotation, or construct it in the specified direction. In the specified direction. In the specified direction. Then after that, now you measure an equal distance and mark the point. That will be the rotated point. That will be the rotated point. So if we are rotating A to the center O, and from O to A prime, after measuring the equal distance from A to O, after the angle, you'll be getting A rotated, or A prime. Something very key, still on the same, something very key, still on rotation. When you are told a quarter turn means an angle of 90 degrees. An angle of 90 degrees. So if you are told that an object went through a quarter turn, it means it has gone through a rotation. A quarter turn means a rotation. It means a rotation, not just an angle. It means a rotation. Through 90 degrees. Through 90 degrees. Again, very important. A positive quarter turn, now specified. Quarter turn, sometimes written as positive 90 degrees. So when you're told that an object has gone through positive quarter turn, or a positive 90 like that, it means a rotation. It means a rotation of 90 degrees in the anti-clockwise direction. In the anti-clockwise direction. But when you hear a negative quarter turn, mostly written as negative 90 degrees. So when you hear an object has gone through a negative quarter turn or negative 90 degrees, it means a rotation. represents a rotation through 90 degrees in the clockwise direction. In the clockwise direction. Therefore, in this language of rotation or transformations, when you hear a positive quarter turn, then it means a rotation through an angle of 90 anti-clockwise. Negative quarter turn, it means an angle of 90-degree rotation, but in the clockwise direction. In the clockwise direction. Therefore, that's all about rotation. Allow me to put something on what we call the third transformation, which will be enlargement. Enlargement. Then we'll be seeing an example. We'll be seeing an example. We'll be seeing an example. Enlargement. Enlargement. To describe an enlargement fully. To fully describe an enlargement, the center of enlargement and the enlargement scale factor are necessary. The enlargement scale factor and the center of enlargement are necessary. And again, we should not, if the enlargement scale factor is positive, for a positive scale factor, then we say that the object and the image are on the same side of the center of enlargement. But if the enlargement scale factor is negative, then the object and the image are on opposite sides. They are on opposite sides of the center of enlargement. Of the center of enlargement. Let me do a little demonstration of what I am trying to put there. A little demonstration of what I'm saying there. If we have the Cartesian plane, let me use this space here. If you have the Cartesian plane here, then we are told that point A is being enlarged and the center is O, and the scale factor, enlargement scale factor is 2, which is positive. When you connect A and the center, then you move 2 steps of this equal distance. 2 steps of this equal distance towards the side where the object is. So you move from the center now 1, and because the scale factor is 2, to an equal distance. Here we'll be getting the transformed hair. But now, if we are enlarging C through a scale factor -2, then we shall connect C to the center of enlargement. But now we'll be moving 2 steps still, but now in the opposite side, on the opposite side. So from the center of enlargement, instead of going where C is, we go further. 1, 2. So the enlarged C will be on the opposite side. So you'll be finding if the scale factor is negative, with C here, the enlarged C will be here if the center is here. So you'll be finding C is here, enlarged C on the other side. But for the positive scale factor, A is here and A prime is here when the center of enlargement is here. Therefore, both A and the enlarged A are on the same side of the center. But for this case of negative, C prime on the other side. Okay, so with that now outline, we can get an example on this. Just an example. And we'll do it right now. We'll do it right now. I'll make sure it is one. Just one example. Okay, I now want to bring the example. Yes. So the example says this: a triangle whose vertices are a triangle whose vertices are A 1, 4, B 2, 1, and C 5, 2 is given the following transformations. Roman 1, a reflection along the line. Y is equal to X to get A prime, B prime, C prime. Then Roman 2, we are told A prime, B prime, C prime is given a rotation of a positive quarter turn. Is given a rotation of a positive quarter turn about the origin. Quarter turn about the origin to give us A double prime, B double prime, and C double prime. And Roman 3, A double prime, B double prime, C double prime is given an enlargement, of linear scale factor -2 about 1, 2, about coordinate 1, 2 to give us A prime, B prime, C triple prime each. So now we are told now to operate all these transformations now. So plot triangle and its image, locate and the state coordinates. So we are just undergoing all this. We are performing all these transformations, and in each stage or after every image we will be stating the coordinates. We will be stating the coordinates. We'll be stating the coordinates. So we can now focus on the grid. Yeah, so we can carry out now the transformations. We can now carry out the transformations. Let me start by plotting the Cartesian plane. So we can navigate here. Remember, we'll be stating the coordinates after every transformation. It's what we call a successive transformations now. When you hear successive transformations, we mean this kind of operations. So 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6, negative 1, 2, 3, 4, 5, as they continue. 1, 2, 3, 4, 5, as they still continue upwards. Therefore, we got coordinates 1, 4. So 1, 4. This is where we have A. 2, 1. So 2, 1. This is where we got B. Then C. C is 5, 2. C is 5, 2. So this is where we have C. So we can first of all come up with the original object, which is a triangle according to the instructions and according to what we can see. A to B, B to C, and C back to A. So that is the object. That is the object. Now we want to see the transformations. The first one is a reflection along the line y is equals to x. Line y is equals to x. So if line y is equal to x, okay, it's a simple line, and the line is this one. Can come up with coordinates of x and y, that we get the straight line. So if x is equal to y, when x is 1, then y is also 1. X is 2, y is 2. x3, like that, x being equal to y. Therefore, when x is 1, y is 1. So this point, when x is 2, y is 2, is coordinate. When x is 3, y is 3. Yeah, therefore, find that this should be the mirror line now. This will be the mirror line. That will be the mirror line. Therefore, now after identifying the mirror line, Now we said something, when we were mentioning the very key issues whenever carrying out a reflection, we said one, a point should be line by a perpendicular line and an equal distance to the other side, an equal distance to the other side. Therefore, we will connect, let me enlarge this, let me prolong this mirror line. So we connect, if we start with A, we shall connect A to the mirror line through with a very perpendicular line, then we proceed an equal distance to the other side. Therefore, standing at A, we will get a perpendicular to the mirror line. Standing at A, we will get a perpendicular to the mirror line. Stand here, make an arc, and standing here, cut the arc. Therefore, from A, this is a perpendicular to the mirror line. That's a perpendicular to the mirror line. So you find this line is very perpendicular to the mirror line. Then now we need an equal distance. From now the mirror line to A, and from the mirror line again to where the reflected A will be. You find we are getting the reflected A now will be here. The reflected A will be there. Again, we get for C, yes. So when we are at C, we get a perpendicular to the mirror line. When we are at C, we get a perpendicular to the mirror line. And now using those arcs, can get cuts on the other side like that. So this will be the perpendicular now from C through the mirror line to the reflected C. So these are very perpendicular line, and we need an equal distance to the other side, and it should be here. So this will be the reflected C. C reflected will be on the other side. Now lastly, we reflect B, and the reflected B will be here. This is a very perpendicular line from B to the mirror line, then we proceed, and we'll be getting, this is very perpendicular, B an equal distance, reflected will be here, B reflected will be here. Therefore it will be A prime B prime. We connect them. Then from B prime to C prime, now we can complete the triangle. So I can see in this case now the image and the object are overlapping, which is okay. Therefore we have A prime, B prime, C prime. They have overlapped with the object, which is okay, no problem. Then after that now, the next thing we do is to go to the second transformation. We are told that A prime, B prime, C prime is given a rotation of a positive quarter turn. So positive quarter turns means anti-clockwise direction. Anti-clockwise direction. Therefore, we shall be bringing a coordinate. If it's C prime, then we rotate in the anti-clockwise direction because it is positive quarter turn. So 90 degrees anti-clockwise. So we connect the center of rotation is the origin. It's the origin. Therefore, to the origin, and we turn 90 degrees anti-clockwise. 90 degrees anti-clockwise. So from the center, 90 degrees anti-clockwise means this side. So we cannot turn this way. We turn that side, meaning anti-clockwise. From here we can construct now 90 degrees. That will be 90. That will be 90 degrees. So we have rotated here. Now to get an equal distance on the other side, we'll have the rotated A here. Double prime. A double prime will be on that point. Then B, we bring B using a straight line to the center of rotation. So we bring B also to the center of rotation like that. And we construct 90 degrees again using the line through which B has come through. So the line 90 degrees. And we produce the perpendicular. We produce the perpendicular. Produce the perpendicular like that. Therefore, from A to B, and after turning 90, we mark an equal distance. We shall have B double prime on that side. Then lastly, C. Lastly, we bring C to the center. C to the center. After bringing C to the center now, we also construct a perpendicular through its line. A perpendicular also. So standing here, you get the point. We extend. bit, then standing here, and standing here, we make an arc. This arc must be intersecting the other like that. We produce bisector which is perpendicular through the center. Like that. Then now an equal distance from just a minute. This perpendicular line is not very perfect. I want to make it clear. So the perpendicular line should pass through the center. It should pass through the center. Pass there. Therefore you find this is 90 degrees. Therefore now from the center to O to C we get an equal distance on this side which would be here. Therefore now second image will be A double prime B double prime, then to C, then to A. Then to A. So that is the rotated triangle. Lastly, A double prime B double prime C double prime, they undergo an enlargement, scale factor -2, and this is happening about 0.12. About 0.12. Therefore, the center is 1, 2. The center of enlargement is 1, 2. Therefore, we will be connecting, because the scale factor is -2. After connecting a point to the center of enlargement, we will be going twice that length on the other side, on the opposite side. Therefore, if we start with A and we bring A to the center, we bring A to the center of enlargement like that. We just prolong the line. Just prolong the line. Just prolong without worrying. Just prolong. Then now come here from the center of enlargement. You will take this length, because it is a negative scale factor. You go 2 times on the other side. Therefore 1 and twice. Stand here. Twice. Therefore you get A triple prime there. Again, we connect B to the center of enlargement. From B, we connect it to the center of the enlargement. B to the center of enlargement. Then from there you prolong on the other side. Can prolong as much as you can. prolonging cannot cause damage to your body. So just prolong like that. Then now, again twice. So from B to the center of enlargement, that's the center of enlargement, 0.12. B double prime is here. Therefore, we go 2 times 1 and standing here twice. Therefore, you find B triple prime is there. B triple. Lastly, we enlarge C. Enlarging C, we connect C to the center of enlargement. Right now the C will fit here. C to the center of enlargement. Then you just prolong on the other side. Just prolong on this other side. Just prolong. Just prolong this line. Just prolong to this side. Therefore, now standing at the center, you can get where C is. C is here. Therefore, we mark once and twice. And see it is going to this other side. So this one we could have extended our Cartesian plane towards this side, but no problem. Therefore, the enlarged triangle A, the enlarged A is here to B. A to B like that is the enlarged one. Then from B to C. From B to C. Therefore, C is somewhere here. Then from A to C again. So this is C triple prime. C triple prime. Now we can 7, 8, 9, 10, 11. So 12 is here and this is 13. That is 13. Therefore, now we can state the coordinates now. State the coordinates. A single prime was A single prime is 4, 1. B single prime was 1, 2. Then C single prime, A, B, C. C single prime is 2, 5. 2, 5. A double prime. A double prime is -1, 4. Then B double prime is here. B double prime is here. So -2, +1. Then C double prime is -5, 2. -5, 2. Lastly, the triple prime A triple prime is coordinate 5, negative 2. B triple prime will be 7, 4. And lastly, C triple prime. C triple prime is 13, 2. 13, 2. So that is how we carry out rotation, reflection, and enlargement. Something on vectors, we said there is a transformation there called translation, and we see that when we take the translation vector and we add it to the object, they give us the image. Therefore, translation vector plus the object, they give us the image. Therefore, we express all in terms of, we express them in terms of column vectors. Therefore, the coordinates of the translating vector, it can be xy plus, if the coordinates of the object was AB, we have it as a column vector. These ones will give us A prime, B prime. So that's a transformation still in book 2. We will study it better when we will be doing the vectors topic. So thank you very much for following. You can share our link with your different friends. Thank you and God bless you.